Okay, so we're starting review number 3, and review number 3 now. It's not due next time. You have a week still, but this one's all about equations. Is every one of these is going to have an equal sign? That's totally different. Let me make this first one bigger. 6x minus 12 is 24. Yeah, got it right there. Make it bigger for you. Oh, this one's long. Oh my goodness, we got to get going. All right. So this is review number 3, question 1. Bless you. 6 minus 12 is 24. All right. So this whole review number 3 is all about equations. How do you solve equations? So what that means is all these problems are going to have equal signs in the middle and going to have a left side and a right side. And so whenever that's the case, all of our thinking now is going to shift to left, right, because you have an equals in the middle, right? If the left and the right are equal, you know the deal, right? And you treat them the same, they'll be equal afterwards, huh? That's called the property of equality. If two things are equal and you treat them the same, they got to be equal afterwards, don't they? We all sense that. That's pretty much the principle we're going to use all the way through this section. The name of the game on every one of these problems, that X is going to be saying, I want to be alone. X is a big loner. He wants to be alone, so we have on his side of the wall, so we have to get rid of everything that's with him on his side of the wall so that he could be alone. But we always do it by doing the same thing to both sides so that we keep them equal. All right, so that means we got to lose the 6 and lose the minus 12 to get that X alone. So what do we do first? Add the 12. We do the adding, subtracting first. We save the dividing for last. Yeah. Add 12, add 12. We do it to both sides. If they were equal before, treat them the same, they'll still be equal. Notice how I come down. I really encourage you. It's not just my thing. Every math teacher does this. Come down in your work. Come straight down. Don't go off to the side. It'll get you all mad. They're going to get way, way, way harder than this one. And it'll really help you come straight down. Every math person does that. Come straight down. Keep a line in the middle. Keep the left and the right. And notice how I added 12 to both and I drew a line. See that line I'm drawing? I encourage you to follow that style I'm writing because it's what everybody does, not just my style. That it makes us think, okay, we're going to add up and write the result of those things. So here we go. Minus 12 plus 12 cancels. Just bring down the 6x. What's on the other side? 12 and 24? 36. All right? That was the result of adding 12 to both sides, wasn't it? See, I put that line, and we just wrote the result. So you have something there. You take action, result. And I'm going to take action, draw a line, result. Take action, draw a line, result. It's just going to keep going like that, right? So now, X is saying, I want to be alone. Should I subtract 6? No, you know better than that. Huh? Why don't I subtract 6 to get rid of that 6 so X can be alone? Because it's times, huh? Right? When that 6 is sitting right next to the X with no plus sign in the middle, it's times, isn't it? And what's the opposite of times? Divide. We're always doing the opposite to get X alone. Yeah, we're going to divide. And when you divide by 6 on the left side, you have no choice but to divide by 6 on the other side. To keep the equality, these 6's cancel. X is alone. 36 divided by 6. And there's our answer. So what did we just do? We found the value of X that makes the original equation true, huh? You don't have to do this. But if you went back up and you put a 6 in the X spot, the left side would equal the right. Right? 6 times 6, 36 minus 12, it's 24. That's the value of X that balances the equation, that brings balance to the equation. Is that good? Let's move ahead then with number 2. Number 2, 1/4 X is 7/8. All right, so on this one, X is saying, same thing he's always saying, I want to be alone. Get rid of this 1/4 that's next to me. So what's going to make that happen?
Times 1/4 by both sides.
Yeah, times the upside down, huh? Times 4 over 1. Does that make sense? Because you want to get rid of that 1/4. You always got to do the opposite. You getting the hang of it? With equations, you're always doing the opposite of whatever's next to X to get him alone.
So you're going to do like times 4 on
So I'm going to go 4 over 1 on this side and 4 over 1 on that side. Does that make sense? Because what will that do? That will cause, remember cross-canceling? In one step, that'll cause everything on the left side to cancel out, and x will be alone. We good there? Does everybody see that? And then what happens on the other side? Say cross-canceling, right? When we're multiplying fractions, we can cross-cancel. So 4 goes into 8 2 times. So the answer is 7/2. And it's okay to leave the top bigger than the bottom. We just leave it like that. Don't need to do anything else. That's our answer. 7/2. So everybody see what happens there? I just multiplied both sides by the reciprocal, it's called. The upside down, the reciprocal. To cancel that out and get x alone. Let's go to number 3. Five times 4 plus 2x is 9 times x minus 2. Okay, so same game. X is saying, I want to be alone. So we got parentheses. So we start by just multiplying through those parentheses, don't we? Can you distribute on the left side and distribute on the right side? Distribute out those terms. And the parentheses will drop off, right? When something from the outside of a parenthesis goes in, we drop the parentheses, don't we? So let that 5 go boom, boom. And we'll get 20 plus 10x. And let the 9 go boom, boom. 9x minus 18. All is well there. And now, what do we do about the fact that we have x's on opposite sides? That's the next issue, right? We have 10x on the left side and 9x on the right side. We don't want x's on both sides. We're trying to get x alone on one side. It doesn't really matter which side, left side, right side, whatever. Just get it alone on one side. We don't want it in two sides. So what do? Do you remember from your earlier algebra classes? What do you do when you have x's on opposite sides? Add or subtract, basically get rid of one of them. It doesn't really matter which one, just get rid of one of them because you don't want both of them. I usually just get rid of the lower one, although you could get rid of the higher one. So which is lower, 10x or 9x? 9x. So I'm going to get rid of the lower one. So let me write the note for you. When x is on both sides, do the opposite of the lower. So what's the opposite of 9x? It's minus 9x. And whatever you do to one side, you have no choice but to do the same thing to the other. Whoops, that line wasn't so good. So I'm subtracting, and it'll cancel that one out, won't it? So do you see what I'm doing there? I'm subtracting 9x from both sides. Subtracting 9x from both sides. It'll cancel out the one on the right. Right? That's how I get rid of the lower one. And then what? And then I see how I drew my horizontal line? I drew a horizontal line because I'm showing the result now of that action. Everybody see how I take an action on both sides? And then I draw a horizontal line. Here comes the result. Bring down the 20 plus, what's 10x minus 9x? 1x, or just x. And then minus 18, huh? Good to there. And now x is still yelling out, I want to be alone. So what are we going to do? What do we got to get rid of?
20.
The 20. You got to get rid of that 20 so x can be alone. So how do we get rid of that 20? Should I divide by 20? Subtract, because it's added, huh? Yeah, just subtract the 20 because the 20 is added. See how we're always doing the opposite. If something's added, we subtract. If something's subtracted, we add. If something's multiplied, we divide, don't we? We always do the opposite to get rid of stuff to get x alone. So draw your horizontal line. So I took the action of subtracting 20 from both sides. And now here comes the result. So these cancel, and the result is 1x is, what's that, minus 38? You can use your calculator, just think money though. If you lose $18 and lose $20, you lost $38. And there it is. Oh, by the way, 1, do I need to get rid of that 1? No. What's 1 times x? It's just x. You don't need to get rid of a 1. Ones are always invisibly there, huh? 1 times x is just x. Just erase it. We're done. Does that make sense? Questions on that one? Stuff coming back? All right. If you're good, I'm going to move ahead. So that minus is going to go boom and boom. It's going to hit both those. And then the next line, there will be no more parentheses. Whenever something's right up against a parenthesis wall, it needs to distribute through the parentheses. So we'll get 8x minus 2x minus 9. Is that good? Does that make sense? What happened there? No more parentheses. The minus distributed. So first, go ahead and just gather like terms. On the left side, 8x minus 2x. It's just going to be 6x, right? So just make that. And these two just make 6x. This seeming okay so far. Here's, notice these two x's were on the same side. So they just combined together, didn't they? Just 8x minus 2x, 6x. No big deal. But these x's are now on opposite sides of the wall, aren't they? It's really important that you're looking at it that way. That equal sign is a wall of separation. Left side, right side. So when they're opposite sides, you got to get rid of the lower one. Here's some of the kind of mistakes I've seen people make over the years. People will go, okay, I know I got to get rid of the lower one, so I'll just go minus 6 minus x. No. Minus 6x. And that matters. How do you know? Well, what are we trying to get rid of? Just the 6? No, we're trying to get rid of the entire... I don't want just the 6 to go away and x still to be there. That's not what I want. Right? I want the whole 6x to go away, don't I? Because I already have my x on the other side. Right? Everybody see that? I'm trying to get rid of the entire 6x because you don't want x in 2 locations. I've already got the bigger one on the right side. So does everybody see why it's not just minus 6, but it's minus 6x? Trying to get rid of the entire 6x. So I draw my horizontal line. I just took an action, right? I just took an action, draw my line. Here comes the results of that action. Whoops, not 9. 9x minus 6x is 3x. Okay, keep going. So I'm going to add 27 to both sides. That's my action. I draw my horizontal line. Here comes the results of that action. These cancel. You can use your calculator. 27 minus 9 is that 18? Equals 3x. Last step is almost always division. It is not always, but 98% of the time. You got down to a number. You got to get rid of that 3. That 3 is times the x. The opposite of times is divide. Divide both sides. So when I divide, I put a bar, right? I'm dividing by 3 on both sides. Cancels it out. X is alone. 18 divided by 3 is 6. X got his wish. He's alone. That means that's the value. If you took that answer back up here and you plugged in 6 for x, 6 for x, 6 for x here, and you worked out the left side and the right side, they would be equal. That's the value of x that balances the equation, that makes the left side equal the right side. I don't got time to work all that out, but that's what that answer means. That's what we're finding. The value of x that makes the left side and right side equal, makes the equation true. Questions on that one? We good with that? Okay. So on to number 5 we go. Number 5 is going to be a little messy now. 2/3 x minus 6 equals 7/9 x. Okay, this one's really important. This is going to be a subtle difference from the last whole review section we were doing, and it's really important that you catch this difference. So everybody feeling sharp here at 4 o'clock in the afternoon? So home with me, I hope. Give me your best mental attention now. This will be really important. This will make life a lot easier for you, or if you miss it, hard. We just finished a whole section on fractions, right? And we learned to do what with those fractions? Same thing, top and bottom, to get common denominators and things like that, right? We're going to not do that the same way here because these have equal signs. None of our thinking is top-bottom. When you have an equal sign, all you're thinking is left-right. Watch this. Don't do this. This is what I see people do all the time. They'll come and they'll go, oh, I got to make those two denominators the same. Got to make 9, so I'll multiply top and bottom by 3. That'll make that denominator the same as the other denominator, and then I can do stuff with it. You can eventually make that work, but it's by far not the easy way to go. Now, you might be, well, isn't that exactly what we did in the last section? It is. That's exactly what we did in the last section. But we're not going to do that here. Why? Because these are equations. This has an equal sign. If you look back to all the stuff we just did in that last section, none of them had a left and a right with an equals in the middle. They weren't equations. They were just big ugly things, and we were making them simpler. They were a couple of fractions added or subtracted, or fractions over fractions, and we were putting them together and simplifying them. This isn't simplifying. This is solving now. We have a left side and a right side. We're trying to get x alone. Different game. How do you think? So when you have an equal sign, right? But that's why I'm really into putting that bar in there and really having you see that. When you have a left side and a right side, all of your thinking, all of your steps, all of your action should be same to the left, same to the right. I'm not thinking top, bottom. That's why that's wrong. We shouldn't even be thinking top, bottom. Top and bottom by 3? I'm not thinking top, bottom. I got an equal sign. I don't care about the bottom. I got an equal sign. All my thinking is left, right. Whatever I do left, I can multiply both sides by 1,000,000 if I feel like it. If they were equal before, and you multiply them both by 1,000,000, they'll be equal afterwards. They'll both be 1,000,000 times bigger, but still equal, right? So my point is, you're not thinking top, bottom. That's the mistake that people make, who don't see that distinction. That's important, and it'll mess you up. It'll be so much harder. So again, main point. If you have an equal sign, don't do top, bottom. All of your thinking should be left, right, not top, bottom. Don't do top, bottom. Okay. Now, by the way, if this was a plus sign here, watch how close it is. If that was simply a plus instead of an equals, then that's exactly what I would do. I would definitely put a 3 top and bottom. That would make all the difference in the world. That's why it's so important that you look at the form of things and don't just dive in and start moving numbers around without really stepping back and going, now what is this? Is this an equation with a left and a right? Or is it not an equation? Just a bunch of separate things to add, subtract. Very, very different in how we'll approach the problem. Even though visually the difference is slight, but the meaning is hugely different. Does everybody see that difference? So if that was a plus, it would not be an equation. Now there would be no equal sign, no left, right. So I would go, okay, top, bottom then. Right. So one more time. In math, we're always keeping the balance. And there's 2 ways to do that. Top, bottom, or left, right. How do you know which one? If you have an equal sign, it's left, right. If you do not have an equal sign, like that one right there now with no equal sign, I would do top, bottom by 3. That would be the right thing to do. Top, bottom. Make sense? So if you do not have an equal sign, so if you have an equal sign, then left, right. Left, right. If no equal sign, then top, bottom. Do the same thing to the top that you do the bottom. That was the last section, wasn't it? The last section, there were no equal signs. There was no left and right. Now we have an equal sign. Did I change the problem? That's it, huh? Yeah. So all of my thinking is left, right, not top, bottom. Okay. Enough with all that. So then what do I, so what? What am I going to do? Well, you got to look at this 3 and look at this 9. And ask yourself, you still have to survey all the denominators and think for a second, what's the common denominator? So step 1, take all denominators and find a number they all divide into. That's called the LCD, least common denominator. So I'm looking at 3 and 9. Those are the two denominators. What is a number that 3 and 9 both go evenly into? 9. Right? They both go into 9. Now, could you multiply them together and make 27? You could. That'd be harder. It'd be okay. It'd work, but it'd be more difficult. The lowest common denominator, least common denominator, LCD, the lowest number they both go into is 9. That'll be easier. So I'm just going to use 9, and what am I going to do with it? Multiply every term, left and right, by LCD over 1. So here we go. 9 over 1, 9, even that's 6. 9 over 1. See how I did all of them? Because you have to. You've got to have equal treatment, don't you? It's an equation. They're equal. The left and right side are equal. So you've got to do all the terms on the left and all the terms on the right by the same exact thing. And that's the LCD over 1. Notice I'm not doing the same thing to the top and the bottom, am I? I'm doing 9 on the top and something different on the bottom. Is that okay? Yeah. Because I have a left and a right. I can do anything I want. If the left and the right are equal, you can multiply by 1,000,000 if you want to, as long as you did it, all the terms on the left, all the terms on the right. They were equal before, they'd have to be equal afterwards. See how all my thinking is left-right, not top-bottom, when you have an equal sign. Okay, so now, what happens? Cross-canceling, right? Remember all the cross-canceling stuff? 3 goes into 9 how many times? 3 times. 3 goes into 9 3 times. So that 3 is left over. The 2 was already left over. Together they make 6x. And the x was left over, right? 3 times 2 times x. Everybody see what happened there? I cross-canceled 3 into 9 3 times. Remember fractions? You cross-cancel? And that's 3 times 2 times x, 6x. Now the next one, the questions on that one so far? This 6, remember, whole number is over 1. So can I cancel the 6 and the 9? No. You only can't, they're going to multiply. 6 times 9 is 54. You only cancel things under a bar with something over a bar, huh? They're both in the top. They're going to multiply. 6 times 9 is 54. You just multiply those guys. No canceling there, because they're both in the top, right? We only cancel bottom to top, don't we? We only cancel things under the bar with things over the bar. How about the right side now? Can I cancel anything on the top with anything on the bottom? Yeah, the 9s. And what are we left with? 7x. Look at that. No more fractions. That's why this is by far the easiest way to do this. Just multiply through by LCD over 1, and you'll be rid of the fractions in one step. Daniel.
I didn't see exactly how you got...
All right, and now the rest is easy, huh? So we have x's on opposite sides. What do we do when we have x's on opposite sides? Get rid of the lower one. Which one's the lower one? 6x. So subtract 6x from both sides. Draw your horizontal line. Now we're going to show the results of that action. This will cancel. So what do we get here? Minus 54. And 7x minus 6x? Plain old x. There it is, and we're done. X is alone. He got his wish. He is alone. We good there? Question. Okay, so there's number 6. All right, so decimals, definitely use a calculator, if you want to, the decimals. So I would just leave them. You could multiply by 10 and get rid of them, but I don't think it's worth it. But go ahead if you want to. I'm just going to leave them and just use a calculator. So anyway, we have x's on opposite sides, left side, right side. We have x's. So what do we do when we have x's on opposite sides? Get rid of the lower one. So go ahead, just use your calculator if you want to, and get rid of the lower one. Okay, so what's the first step? Subtract 0.2x from both sides. Does that make sense? Because that's the lower one, right? 0.2x. Now, and then see the horizontal line I draw, and now I'm going to show the result. What's left on the left side? Nothing. But go ahead and write 0. That'll be helpful. Don't just leave a blank. I mean, it's okay if you leave a blank. But I think it'd be easier if you write 0, because then you'll know there's actually a number there, 0, equals. And then the other side is that, right? Sometimes people get messed up when they put nothing and then they drop the equals and then they get in trouble. Keep the equals, keep a 0 over there. So now x is still saying, I want to be alone. Get rid of all this stuff. It doesn't matter right side, left side. Right side's fine. What do we do next to get x alone? The point 1, huh? Draw your line, cancels out. We good there? So I'm always doing the opposite of whatever's with x to get x alone. Subtract 0.1 from both sides, and you get negative 0.1 equals 0.5x. Does that make sense? I just subtracted 0.1 from both sides. Last step is usually divide. It's usually divide, right? When you got something right next to x, that's 0.5 times x, so get rid of it by dividing. Divide by 0.5. Now, I would just use my calculator. Just take your calculator, and go 0.1 divided by 0.5. It'll tell you 0.2, and it's negative, right? Because we have a negative sign there. So there we go. Negative 0.2. How we doing? Questions I can answer? So this is number 7. Notice we've got denominators. So what do we do when we have denominators? Go back to number 5. That one had denominators. And so what do you do when you have denominators? You got to find the common denominator and multiply LCD over 1, LCD over 1, LCD over 1. All the terms on the left, all the terms on the right. So let me write a note for that again. For fractions, find the LCD. What is the LCD? Yeah, it's just going to be y, right? LCD is one of each type for letters. For numbers, it's the number they go into. For letters, it's just one of every type, right? We don't need both y's, right? Remember that? We did one of those in the last section where we had a couple x's and we talked about the LCD. So you need one of each, and you multiply LCD over 1 to every term left and right. Multiply LCD over 1 to every term left and right. Because all of my thinking is left side, right side when I have an equals. I'm not thinking top, bottom. I'm not going to try to do the same thing top, bottom. I'm going to try to do the same thing to the left and the right. All the terms on the left and the right. All of my thinking is left, right when I have an equals, right? So I come in and I go, okay, so LCD is y over 1. Y over 1. Y over 1. Does that make sense? Y over 1, Y over 1, Y over 1. LCD over 1. Do you see why the LCD is only a single y? You only take one of every letter type when you do an LCD. So can you take it from there? Cross cancel now and bring down what's left over. Okay, so time to cross cancel. So I'm going to cancel these y's out and these y's out, right? So 8 plus 4. And what happens on the right side? Can I cancel anything on the right side? Nope. Just 4y, right? There's nothing to cancel. There's nothing matching top and bottom. Everybody see that? See how there's no more fractions? That's what's great about this method. It gets rid of the fractions in one step for you. See how that worked? It canceled out both those y's on the left side. And so what are we left with? 12 is 4y. Last step on most equations. Most equation solving problems, last step is? Divide both sides by 4. Huh? So that's going to be 3 and we're done. Questions I can answer on that one? Try that one. So the first thing to do on that one is to go ahead multiply the two terms with the two terms on the left side, first to both, second to both. You got to multiply out the parentheses on the left side, and then on the right side, same thing. That means x plus 1, doesn't it? So you got to write two of those and do the same thing. So let's do that. That's our first step. So this first one will go to both. X squared minus 2x, and this one will go to both. Plus 7x minus 14. The other side, this means x plus 1, x plus 1. So that goes to both. X squared plus x, boom, boom. No, plus 1x, plus 1x, plus 1. Is that making sense there? So first step, I just multiply out the parentheses on the left, multiply out the parentheses on the right. And now go ahead and gather like terms. Can you gather like terms on the left and on the right there? So these two, so this would be x squared plus 5x minus 14. X squared plus 2x plus 1. Is that good? I just combined like terms, x's with x's. Now notice, everybody good to there? Notice that we have x squared, the exact same amount of x squared, just one plain x squared, one plain x squared. Both sides, same thing. Guess what we're going to do? How can we get rid of both of them? Just subtract x squared from both sides. Bye-bye, right? It's an equal sign. We can do anything we want to the left side and the right side. So I'm going to subtract x squared, gonzo, gonzo. So that brings down 5x minus 14, 2x plus 1. They drop out. When you have the same amount of something on both sides, they're gone. You just subtract it from the left side and the right side. Gone. All right, you know how to finish from here, right? You finish it up. You got x's on opposite sides. Remember, get rid of the lower one. Do it to both sides. Get x alone. All right, so which one's the lower one? 2x is lower than 5x. So we subtract 2x from both sides. And what do we get? 3x minus 14 is 1. And x is saying, I want to be alone. So get rid of the 14. Add 14 to both sides. These cancel. 3x is 15. Last step is usually divide. Divide by 3. So x is 5. 15 divided by 3 is 5. Questions there? Is that good? So number 9. X squared is 4x. Okay, things are going to change here. Let me give you some instructions. So if you have x squared with an equal sign. So how do you solve problems that are x squared with an equal sign? Step number 1. Get a 0 on one side. Step number 2. Try to factor and set each part equal to 0 and solve. Okay. So there's the steps for how you handle x squared with an equal sign. That's what's just changed. Do you notice that if you look back at the first 8 problems, numbers 1 through 8, there was no x squared in any. Well, there was one, in the last one, but it dropped out, didn't it? Right. The last problem had x squared, but it dropped out because we had the same amount on both sides. So we just subtracted x squared from both sides and it vanished. But all the rest of the problems didn't have any x squareds. So this is really the first time we've had x squared with the equal sign and it's staying. It's not going to drop out. So what do you do when you have x squared with an equal sign? Step one, you got to get a 0 on one side. How can you get a 0 on one side? Yeah, subtract the 4x, right? This is the wall here, right? Draw your line, draw your horizontal line, and write the result of what you're doing. I'm subtracting 4x from both sides. So what does that leave me? X squared minus 4x equals 0. See how these cancel out and leave 0? So that gets us a 0. So that's step one. Now step two is try to factor. Can you factor this? That was last night's homework. I'm hoping you're somewhat comfortable. Can you factor? Can you do the parenthesis? Now is that one going to be 2 parentheses? No, because it's not 3 terms. Do you know what I mean? If it was 3 terms, if it was like x squared minus 4x plus 12 or whatever, then I would do the 2 parentheses, huh? If it was 3 terms, I would do the 2 parentheses. Or if it was a difference of squares, yeah, that's right. It's almost x squared minus 4. If it was x squared minus 4, it would be x plus 2x minus 2. That would be 2 parentheses also. But it's not quite. It's x squared minus 4x. That's a little different. Well, what do we do that's different? How do you factor x squared minus 4x? What do they have in common? X. Yeah, you just take out what they have in common and you just do 1 parenthesis, not 2. Do you see the difference? You getting the hang of that? X squared minus 4, if it was x squared minus plain 4, that would be different because they would not both have an x. They would have no x in common. I couldn't do the common. I'd have to do the 2 parentheses, right? Or if it was 3 terms, then I would definitely do the 2 parentheses. But in this case, x squared and 4x, they both have an x. They both have an x. So I take it out. What does that leave on the inside? Remember when we take something to the front of one big parenthesis? Yeah, exactly. Whatever works, right? X times x will go back to x squared, and x times minus 4 will go back to minus 4x, won't it? That good? Remember that? Taking out what's in common, GCF, greatest common factor. Okay. Now, so there was the try to factor we did, and set each part equal to 0. So that means at this point, I'm going to take the x alone equal to 0, and the x minus 4. I'm going to break it into 2 equations. You take each part alone, set each part equal to 0. So we had x times x minus 4 equal to 0, and we made 2 separate equal zeros. Hold on. I don't want to do math like it's a bunch of, putting together a new table or something. Step 1, put leg into joint A3, and there's no reason for anything you do. No, I want you to see the reason. It'll stick with you better, make more sense. Why is that logically true? Here's why. What if I said, hey guys and gals, I'm thinking of 2 numbers in my head. Okay, I am. I've got 2 numbers in my head, and when I times them, the answer comes out 0. What do you know about my numbers? If I'm thinking of 2 numbers, if you multiply 2 numbers and the answer is 0, what do you know about one of the numbers?
It's a 0.
Yeah, right? If you times 2 numbers and the answer is 0, one of them 0, huh? Well, that's the first one could be 0, because 0 times anything would be 0. Or the second one could be 0, because anything times 0 would be 0, right? Well, that's exactly what this equation is saying. Do you see it? It's saying something times, right? Parentheses is times, right? Something times something what? Equals 0. It's saying 2 things are timesing, and it's coming out equal to 0. So what does that mean? The first thing could be 0, the x alone, or the second thing could be 0. Right? First thing is 0 times anything would be 0. First one could be 0. Or the second one could be 0, because anything times 0 would be 0. It means either one could be 0 to make that true. See how that's reasonable? Makes sense? Right? If two things times to be 0, either one could be 0 to make them times and be 0. All right, so that's why we do that. Now this one is all done. X is alone. But the other one, X is not quite alone. He's almost alone. What do we do there to finish getting X alone? Add the 4. And 4 cancels out. Bring down the X. X is 4. Bless you. And that's it. So we have two answers? We have two answers. There's actually two answers to this problem. So how do you enter it on Math Excel? They want you to put in 0, 4. Either order, you can put the 4 first and then the 0. It doesn't matter at all. Just both answers separated by a comma. Hey, are those really both true? Let's go back and see it. I don't normally take time to do this, but it'd be worth it here. If you put in 0 here and 0 there, are you telling me that makes it true? Of course it does, huh? 0 squared definitely equals 4 times 0. We should have seen that one coming, huh? Well, does 4 work also? If I put 4 here for x, 4 squared, what's that? What's 4 squared? 4 squared? 16. And what's 4 times 4?
16.
Yeah, that makes it equal also. See how 0 or 4, either one makes the equation equal to itself? Those are both the answers that balance the equation, make the equation true. 0 and 4. So this is really important, these steps. We'll do these again and again for x squared problems, or even higher. Let's try another one. How about number 10? X cubed minus 24x squared equals 0. Try the same thing. You know step 1, get a 0. Of course, we already have a 0. They already did step 1 for us. We've already got a 0. So, and then step 2, factor. So factor that left side. Take out what's in common, put 1 parenthesis. See what you can do. All right, so how do we factor that left side? What do they have in common? X squared. Remember, you take the greatest common factor, the greatest amount they have in common. Right? One of them has 3 x's, the other has 2. What's the most they have in common? 2. They both have at least 2, don't they? So x squared times what will go back to x cubed? X, because the invisible 1 power will add, right? And x squared times what will go back to minus 24x squared? Minus 24. Good to there. So that was all from last time. If you're rusty with that, you need to spend some time with the tutor on really getting that last section of factoring down. Factoring is really important. All right, let's keep going. Now what do we do next? So step 1, factor. Then each part equals 0 and solve, right? Because if two things are timesing to equal 0, either one could be 0 to make that happen, huh? So the first one could be 0, or the second one could be 0. It becomes two equations, doesn't it? 2 equals 0s. Because if two things times to equal 0, the first one could be 0, or the second one could be 0 to make them times and be 0.
So it can be x squared, and that can still be your answer. Like you don't have to like.
Nope.
My mind wants to like square root it. And
We're gonna.
bring
Yeah,
it
no, we
x
got to get
down.
it to regular x. You're right.
Okay.
You're thinking correct. Yeah, so what do we do to turn that into normal x?
Square root it.
Yeah, good job. Square root it. Do you remember that from earlier algebra days? Square rooting cancels squaring. And square root of 0 is just 0. Yeah, we do have to do that. Good point. Okay, we got to make it regular x in the end. So square rooting cancel. One of our review days will be on roots. I can't remember which one. Coming up here pretty soon, this week or next week. We'll talk a lot about roots. I'll remind you of all kinds of things about roots. The other one, what do we got to do to get x alone over here?
Add the 24.
Add the 24. Cancels out. X is positive, normal 24. So what are our answers? 0 and 24. 0 and 24. Is that making good sense? Are we good there? I think that's